Welcome to Connected Components of Chaos, brought to you by Amcantech. Today, we are discussing advanced object-oriented programming diagrams and charts. So, chaos. Why that word? Well, if you've ever looked under the hood of modern software, you know what I'm talking about. It's this massive, sprawling universe of parts, all connected, all talking to each other. The complexity is just, wow. It can be totally overwhelming. So let's get into it. And here's the real kicker, right? Software isn't built by one person in a garage anymore. A project is a huge team effort. You're talking about tens, maybe hundreds of thousands, even millions of lines of code. There's just no way any single person can keep all of that in their head at the same time. It's impossible. And that really gets to the heart of the matter. As humans, we're great with big ideas, with abstract concepts, but ask us to juggle thousands of little tiny details all at once? Our brains just aren't wired for it. And that fundamental limitation, that's exactly why we had to invent special tools. We need them to navigate all this complexity so we don't just drown in the chaos.
Okay, so how do we tackle this? The answer is we draw maps. We create blueprints for our code. Think about it, right? An architect would never, ever try to build a skyscraper without a detailed plan. It'd be insane. And it's the same for software developers. We use a visual language to map out the entire structure. And that language, it's called the Unified Modeling Language, or UML for short.
So UML diagrams really break down into two main types. First, you've got static modeling. This is like the blueprint of a car. It shows you the engine, the wheels, the chassis, all the parts and how they're put together. It's the structure. Then you have dynamic modeling. This is like a video of the car driving. It's the choreography. It shows you how all those parts actually work together over time. Let's dive into the most important blueprints of them all, the class diagram. This is a static one. It's really the master plan. It lays out every single major piece of the system. We call them classes. And for each one, it shows what information it manages, what actions it can perform, and crucially, how it's hooked up to all the other pieces. And like any good blueprint, these diagrams have their own special language, their own grammar. These symbols you see here, they're super important. They tell a developer what's public, what's private, and so on. A little plus sign means that part of the code is open to everyone. A minus sign, that means it's private, strictly for internal use. It's a lot like a real building blueprint that shows you which walls are just for show and which ones are holding the whole roof up. But here's the thing. A static blueprint, it doesn't tell the whole story, does it? It's not enough to know how the system is built. You need to know how it works. You need to see the action. So let's flip the coin and look at the dynamic diagrams, the ones that model how the software actually behaves. First on our list is the sequence diagram. I love this one. The best way to think about it is like a playbook for a football team. It maps out one specific play, say logging into an app. It shows step by step which part of the code talks to which other part and in what exact order to make that login happen. It's all about the timing, the sequence of messages. All right, next up is the state chart diagram. Now, this one's different. Instead of showing a bunch of different parts talking to each other, this one puts a microscope on just one single component. It maps out its entire life story, you could say. It shows every possible state it can be in, like on, off, standby, and exactly what has to happen to push it from one state to the next.
A dishwasher is actually a perfect real-world example of this. You know how it works? It starts out off. You hit the start button, that's an event, and it kicks over into the washing state. After a timer goes off, another event, it moves to rinsing, and then finally to drying. A state chart is just a way to draw that whole predictable journey.
Okay, so you might be thinking, this sounds like a lot of work. Drawing all these detailed diagrams, why bother? What's the ultimate goal here? Well, it's actually pretty simple. It all boils down to one thing: quality code. So what do we even mean by quality code? It means it's easy to write. It's easy for someone else to understand. It's easy to change later without breaking everything. It means you can reuse parts of it. It's reliable. And, super important, it allows a whole team to work on it together without stepping on each other's toes. That's the key takeaway here. These diagrams aren't just for show. They are the practical, hands-on tools that make all of that possible. And this is probably the most important rule of all. These diagrams, they're not suggestions, they're not just nice ideas. They are the plan. They're the official blueprints. You can think of it like a contract, really. It's on the developer to build the software exactly like the diagram says. That's how you make sure that everyone on the team is building the exact same thing the right way. So, I'll leave you with a little something to think about. The next time you're using an app on your phone, you tap a button and something magical happens, just take a second. Think about that invisible world humming away underneath. What hidden blueprints and what complex choreography do you think are running right now, just to make that one little thing possible?